Wouldn't it be great if you could directly digitize RF signals and then use on-chip signal processing to mix and filter? Well, now that's possible with the AD9625, a new 12-bit 2.5 gigasample per second A to D converter from Analog Devices. I'm Frank Merton, ADI Fellow with the High Speed Converter Group. Before we move to the lab, let's take a look at the AD9625 block diagram. There are three key blocks in the AD9625. A 12-bit 2.5 gigasample per second ADC core capable of digitizing signals up to 3 gigahertz. Two separate digital down converters, DDCs, with programmable filters, and a JESD204B output interface. Let's go to our lab setup. We'll begin by inputting a 1.9 gigahertz minus 1 dB full-scale analog signal into the ADC and sample it at 2.5 gigasamples per second. We'll bypass the DDCs so we can examine the linearity and noise of the full FS/2 spectrum. Since we are in the second Nyquist zone, the fundamental frequency is aliased to 600 megahertz. What really jumps out when examining the FFT is just how linear the sampled signal is. The second and third harmonics are better than minus 77 dB full scale. These are really impressive numbers and are very representative when considering the added effects of IP2 and IP3 impairments to your system. Also note the SNR is 57.5 dB full scale. A clean, low jitter clock source should be used so you won't desense the noise floor. Now let's exercise one of the AD9625's DDCs. We'll mix the 1.9 gigahertz RF signal down to DC via the 10-bit NCO and set the complex decimation filter bandwidth to 240 megahertz. Both functions are done by writing to the serial port. Now take a look at the filtered spectrum. The second and third harmonics have been filtered, and the higher order spurs are below minus 85 dBFS. Note that the SNR has increased to 63.7 dBFS. This is due to the processing gain of the decimation filter. Since the FS/2 spectrum has been filtered and decimated, now only two JESD204B output data lanes are needed. So there you have it. You've seen the capability of the AD9625 to digitize RF signals while maintaining superior linearity and SNR, and also its ability to digitally mix, filter, and decimate. These on-chip functions can greatly reduce the signal processing requirements of your FPGA. Thank you for watching, and stay tuned for future videos from the High Speed Converter Group. For more information on the AD9625, including datasheets, technical articles, samples, and evaluation boards, please visit analog.com/AD9625.